Unit 1 Review, Problem 4. 25 different automobiles were tested in dry conditions at a speed of 65 miles per hour for total stopping distance. The sample results, measured in feet, are given below. Part A. Calculate the standard deviation for this data and interpret the result. So we can use our calculator to calculate the standard deviation for us. But after we calculate the standard deviation, we then have to provide a written interpretation. That is, we have to write in words of the problem explaining what this standard deviation means. So to calculate the standard deviation on our calculator, we first need to enter all the data into a list in our calculator. To do this, we would press Stat, enter the data editor, and pick a list, like list 1. And then we could enter each of the data values in our list 1, one at a time, followed by enter. And then to calculate the standard deviation, we press Stat, arrow over to Calc, the Calculate menu, and press Enter. This brings up the 1-bar stats command. Second one brings up list 1, press Enter, and now the calculator displays all our calculated statistics on the data that we entered into list 1. Here, to find the standard deviation, we have to know whether the data we have is a population or a sample. So the data we have here are sample results. That is, the 25 data values we have didn't come from 25 automobiles that were the entire population. That is, instead, these 25 automobiles were just a sample, some of the automobiles in the larger population. The sample standard deviation is denoted by the S sub x. So looking at the calculator screen, we can then see that the calculated standard deviation for the sample data, S sub x, equals 4.987317248. We can use all these decimal places to write our answer, or we can round off. But when you round off results, we want to make sure that we round off carrying at least one extra decimal place than the accuracy we need in this problem. So in this particular problem, we look to the data. The data, or total stopping distance measured in feet, were all written to the nearest whole foot. That is, there were no decimal places in this data. So if we are going to round off, we need to carry at least one more than a whole number, or in this case, to the nearest tenth of a foot. So rounding off this answer, carrying the one extra decimal place beyond the data, we see that the second place after the decimal point was an 8. Since the 8 is the 5 or higher, we round the 9 up to a 10. So we write that as a 0, carry the 1, 4 and 1 make 5. So we could round this answer S sub x to 5.0. So now we've calculated the standard deviation for this data. Next, we need to interpret the result. An interpretation provides meaning for this result. So our sample standard deviation of 5.0 needs to be interpreted in words of the problem. First of all, the units. This is 5.0 feet because the stopping distance was measured in feet. And then we have to know what a standard deviation is measuring. The standard deviation is measuring the deviation or variation in the data on how spread out it is from the mean on an average. So that standard deviation is sort of the average deviation. The data is from the mean. So all three of those important concepts need to be included in our interpretation. You also need to include the wording of the problem in the interpretation. In this case, the total stopping distance for automobiles traveling at 65 miles per hour in dry conditions. So one acceptable interpretation of this result would be, on average, the total stopping distance for these automobiles traveling at a speed of 65 miles per hour in dry conditions varied about the mean total stopping distance by about 5.0 feet. So that answers part A. Now we can answer part B. According to these results, would it be unusual for an automobile traveling at 65 miles per hour in dry conditions to take a total of 358 feet to come to a complete stop? So here the question is asking if this particular result would be unusual. Statistically, we determine if something's unusual by calculating a standard score. A data value is considered to be unusual when it falls 2 or more standard deviations from the mean. And the standard score calculates the actual number of standard deviations a data value is from the mean. So here we need to calculate the standard score for this data value, and then the answer would be yes, it is unusual if that standard score is 2 or more. That is either +2 or higher, or -2 or lower. But if the calculated standard score falls somewhere between the -2 and +2, that means it falls less than 2 standard deviations away from the mean. The answer would be no, it's not unusual. To calculate a standard score based on sample data, we use the formula T, which is the symbol for the sample standard score, is equal to X, our symbol for the data value. In this case, the data value in question is it unusual to take a total of 358 feet to come to a stop? So we convert the 358 feet into a standard score by subtracting X bar, the mean for the sample of data, divided by the S sub X, the sample standard deviation for the data. So we have the data value X in question, 358 feet. We also calculated earlier using our 1var stat command the sample mean X bar and the sample standard deviation S sub X. So using this, we can calculate that T is equal to the 358 feet, the data value in question, subtract X bar, the sample mean, which was calculated to be 346.04. And all this is divided by S sub X, the sample standard deviation. Here I wrote it as 4.987. That is, I carried 3 places after the decimal. In part A, we rounded the sample standard deviation to just the nearest tenth of a foot, or 5.0 feet. But in this problem, we're calculating the standard score. And it's customary for standard scores to be rounded to the nearest hundredth, or 2 places after the decimal. And so if we're going to use any number in the calculation of the standard score that needs to be accurate to 2 places after the decimal, we would need to input numbers carrying at least 1 extra decimal place than the accuracy we need in this problem. So that means we need to carry the 3 decimal places in the calculation in order to have our final result have accuracy to 2 places after the decimal. So rounding SX, the sample standard deviation, to 3 places after the decimal gave us the 4.987. So we can calculate the standard score in a calculator by first grouping the numerator and going left parenthesis, 358, subtract the mean, 346.04, close parenthesis, divided by the standard deviation of 4.987. Enter. And here we get the standard score of 2.398235412. But with standard scores, we just need to round off to the nearest hundredth, or 2 places after the decimal. So when you look at the 3rd decimal place, it's an 8. 8 is 5 or more, so the next decimal place over, 9, rounds up 1. So the 9 rounds to a 10, which we write as 0. Carry the 1, 3 and 1, make 4. So the standard score rounds to 2.40. So now we can answer the question. Would it be unusual for an automobile traveling at 65 miles per hour in dry conditions to take a total of 358 feet to come to a complete stop? Well, the vehicle that took 358 feet to come to a stop falls 2.40 standard deviations above the mean. This is more than 2 standard deviations. So anytime a data value falls 2 or more standard deviations away from the mean, it is considered to be unusual. So the answer to part B is yes. But we need to, in addition to answering the question, yes, we need to show our reasoning and method of solving the problem, in addition to showing all our work. So we showed our work to calculate the standard score. We know the answer is yes, so we'll write yes, but we also have to provide that reasoning and method that led to our yes answer. So the answer to part B could be yes. According to these results, it would be unusual for an automobile traveling at 65 miles per hour in dry conditions to take a total of 358 feet to come to a complete stop, since the corresponding standard score of 2.40 is +2 or higher.